This is Crash Course Geography. Extra credit. When we think about the Earth's surface, we tend to think of it as still, even though everything on it is constantly moving. Everything from rocks to water, to the atmosphere, to us humans, and even the planet itself are all in constant motion. But why? What drives these movements? Hi, I'm here with Crash Course Geography. And in this episode, we're going to look at the two main driving forces behind movement on Earth's surface, heat and gravity. Now, heat causes movement in both the short term and the long term. In the short term, heat from the sun causes currents in the atmosphere that move weather patterns around the globe and drive ocean currents. It also causes convection currents in the mantle, which is the layer of rock between the Earth's core and crust. These convection currents make up Earth's dynamic system of plate tectonics, which we'll talk more about later. But first, let's look at how heat causes movement over longer timescales. The Earth's internal heat engine, which includes the core and the mantle, is powered by the decay of radioactive elements. As the stuff inside the Earth decays, it releases heat. The Earth's core is the hottest part, but heat can't easily escape because the core is surrounded by the mantle, which is a solid rock. So the heat passes through the mantle, creating temperatures high enough to melt some of the rock and create pockets of liquid magma. This heat and pressure from deep within the Earth cause convection currents in the mantle. Warm magma moves toward the Earth's surface, while cooler magma sinks. The slow churning of the magma causes the plates of the Earth's crust to move, which is a process called seafloor spreading. At mid-ocean ridges, where new seafloor is created, magma spills out onto the surface, creating new crust. The Earth's magnetic field also helps us understand seafloor spreading because as magma cools, the magnetic particles in it align with the Earth's magnetic field at that time. So we can read the magnetic tape of the ocean floor to tell when and where the seafloor was created. We know that the Atlantic Ocean is getting wider, so we know that new seafloor is being created at the mid-ocean ridge that runs down the center of the Atlantic. On the other side of the ocean, the Pacific plate is sliding beneath the North American plate and the Eurasian plate. This process is called subduction. Where the plates meet, one plate is forced under the other and moves toward the Earth's core. As the plate descends into the hot mantle, the intense pressure and heat melts the plate, recycling the materials back into the mantle. The process of seafloor spreading and subduction renew the Earth's crust and recycle materials from the mantle to the crust and back again. But the Earth's crust isn't the only thing that's constantly moving. The lithosphere, or the rigid outer part of the Earth that includes the crust and the uppermost part of the mantle, is broken into tectonic plates that move on top of the semi-fluid asthenosphere. And the plates don't just move apart and come together. They can also slide past each other. For example, the San Andreas Fault in California is a transform boundary where the Pacific plate slides horizontally past the North American plate. Most of the time, the plates only move a few centimeters per year, but sometimes they get stuck and the stress builds up until the rocks break and there's an earthquake. And then there's gravity. Gravity affects objects on the Earth's surface, large and small. It pulls water off mountains, creating waterfalls and carving valleys. It causes rocks to fracture and fall, creating cliffs and talus slopes. It pulls people and their belongings downhill, creating landslides. And over millions of years, gravity has shaped the Earth's surface by pulling sediment down slopes and into the oceans and creating mountain chains. So we can observe the effects of heat and gravity constantly shaping and reshaping the Earth's surface. Even human activity, like building a road or a dam, can't stop the effects of heat and gravity. Heat and gravity also interact with each other. For example, gravity causes water to flow downhill. As water flows, it erodes the land, which can create new landforms or change existing ones. The interaction between heat and gravity create many of the landforms we see on the Earth's surface, from the tallest mountains to the deepest valleys. Next time you're outside, take a minute to appreciate the forces of heat and gravity that shape the land around you. Thanks for watching this episode, which was filmed at a studio and made with the help of all these nice people. If you want to help keep this course free for everyone forever, you can join our community on a crowdfunding platform.